Hey guys, welcome to Section 3, Chapter 6 of the Pre-Algebra program. And in this section, we are going to put what we just learned about proportions to actual use. So we're going to learn to deal with something called scale drawings and models. And this is really helpful for us when we're dealing with the real world and we're creating things like buildings and towns. And we can set up a proportion known as a scale drawing so that we can get a sense of what our building or town would look like on paper before it's actually built. So today's video is going to be pretty short, and the assignment today is going to be short, but we are going to work on this again tomorrow. I will have another worksheet for you just to give you a couple opportunities to practice this. So hopefully it won't be too bad. So just so our terminology is correct, the scale factor, which you're going to hear sometimes when we talk about scale drawings, is the ratio of information we're dealing with in simplest form. So it's a fraction in simplest form. And the example that we're going to work on today uses this scale factor. So we are going to construct the length of an actual classroom, principal office, and library for a school that's being built. And our scale factor is 1/2 inch. Equals 4 feet. So this is our scale factor. And this is what we're going to use to compute the actual length of the classroom, the principal's office, and the library. Okay, so let's do that. Let's just jump right in. Let's use our scale factor of 1/2 inch to 4 feet and find the classroom. Now, on our sheet of paper, it looks like the classroom is 5 inches long. So in order to line this up appropriately, you need to make sure that the same units are on the same level of your fraction. So for us in this scale drawing, inches is on top and feet is down below. So that means when I set up my equal proportion, inches better be on top, which is what we know. And then what we're looking for, which is the actual feet of this classroom in the real building, needs to go on the bottom. So the order of your scale factor doesn't matter. It only matters how we set up the second proportion that we're looking for to find the piece of information we're looking for. Okay, now, since we know that the scale factor makes these proportions in proportion, then I can use the skill we learned yesterday and set up my cross products to equal each other. So I'm going to have 1/2 x equals 4 times 5. We learned that yesterday that if two things are in proportion, their cross products are equal. So that is our trick for today. Now we identify the variable here, it's x. And it's being multiplied times 1/2. So remember, we undo multiplication with division. So that would give me, well, 4 times 5, which was 20, divided by 1/2. Now remember, we reviewed this last chapter. When we divide by fractions, it's the same thing as keeping the top number the same and flipping the bottom so that I can multiply straight across. And when I do that, I get 20 times 2, which is 40, of course, over 1, which is just 40 feet. So the length of our classroom is 40 feet. All right, the second thing that we wanted to find was the length of the principal's office. And the principal's office measured 1.75 inches on our scale model. Okay, so I'm going to use the same scale factor. 1/2 inch is the same as 4 feet. to set up the proportion that I need to solve how long in real life is this principal's office. So again, they give me the number 1.75 inches, and inches has to go on top again because my inches is still up top here. And once I set that up, then I'm able to set up my cross products. So I get 1/2 x equals 4 times 1.75. And hopefully you guys did some review of multiplying fractions yesterday. So 4 times 1.75 is 7. And I'm going to divide again by 1/2 because we identified our variable. And remember, I take that second fraction, flip it so that I can multiply straight across, which is just 14 feet. So the principal's office is 14 feet in length. Okay, we're going to do that final example here for you. And this was to find the length of the library. And they tell us that that comes in at 7.5 inches. So I'm going to use my scale model, 1/2 inch, or my scale factor, I should say, to 4 feet. And again, I know inches, so that needs to go on top here. What I don't know is the feet. All right, at this point, we can set up our cross products again. So we have 1/2 x equals 4 times 7.5. All right, so now you have two options with this lovely mixed number. So in order to multiply it times the 4, you could either convert the 7.5 to a decimal, and hopefully you know a half is 0.5. Or you could convert the 7.5 to an improper fraction. So you could do 4 times 7 plus 1, which is 15 halves. I really like fractions personally, so I'm going to go ahead and make the conversion to the improper fraction. Decimals are totally overrated. Oops, excuse me. Hold on, let me fix that. And now I can multiply across here. So remember a couple of sections ago too, we talked about looking to cross reduce. I'm looking at my cross products here, and 2 can go into 2 once, and 2 can go into 4 twice. And now I can multiply straight across. 2 times 15, which is 30 over 1. All right. Now I can rewrite what I have. Of course, we hadn't done anything to the left-hand side yet. And then we multiplied 4 times 15 halves, which gave me 30, or 30 over 1. And now I'm going to divide by a half again. Again, I'm isolating this variable x. And again, we're going to take that second fraction, flip it, and multiply straight across to find the length of the library, which for us is 60 feet. Okay, the example in the text is very similar, and your assignment for today is very similar to this, so you shouldn't have any trouble. And then, like I said, we're going to do a worksheet with more scale drawings tomorrow to just give you lots of practice, but hopefully you guys won't struggle too much with it. So go ahead and finish up your notes. Take a look in the book, look through the examples, and begin your assignment.